At Vision Miner, we've been working with AON3D since early 2018. And today, I'm going to show you the latest offering that we're adding to our lineup of performance 3D printers. And that is the AON Hylo. If you're into high-performance thermoplastics like PEEK, PEC, Ultum, or even engineering-grade plastics like ABS, ASA, nylon, polycarbonate, or all the composites thereof, this is the machine that will enable you to not only go full prototyping of large parts, but full production and quality inspection. Powered by machine learning, it's the world's first AI-driven 3D printer. All of that and much more. So let's get right into the specifications. If you're interested in Hylo, reach out today and we'll get on a one-on-one consultation to make sure it's the right fit for your application. On this machine, you'll notice it's a wider build area. It's at 450 millimeters by 650 by 450 millimeters. So as the trend has been going that we see in the industry, having a wider bed is actually more advantageous than a taller bed. Whether you're doing a large part that's wide and long, or if you're doing a large batch of parts. Next, we've got the chamber itself is heated to 250 Celsius. That's good enough for any material on the current market, as well as the 500C nozzle so that you can extrude any material currently available. And then, of course, the 250 Celsius bed. Now, there's a lot of things that make this machine really stand out, and a lot of that does have to do with the in-process sensors, but also how those integrate with the software. In general, when you're buying high-temp machines, especially in the open market, you're gonna really pay a lot less for the open material systems. You're gonna need an experienced operator to really run them. Now the Hylo is changing all that. With the integration of the sensors and the software and the AI machine learning driven simulations, it's bringing high-temp open material systems to the use of, your janitor could basically start a print on this thing. That's how easy it really is. So, going through some more of the specs, this machine will actually print at speeds up to 500 millimeters a second, and that's actual print speeds. Material dependent, of course, but with the chamber and everything else going on for you in the thermal simulations beforehand, you can really crank that to get parts out faster. Add that with design for additive manufacturing, and you're gonna be hitting speeds that you've never seen in production before. And of course, it is an open material system, which means you can run any 1.75 millimeter filament that you can get your hands on through this machine. Now the Hylo is really to enable easy, high quality results and ultra high throughput and speed of production. And it's got industry leading part performance, and that's mostly due to the simulation and then the sensor feedback and quality validation integrated into the machine. You get quality parts that you can trust because you're watching the entire process with thermals, with cameras, with all kinds of sensor data and input that's all recorded throughout the printing process, but also simulated beforehand and then saved. So if you have parts out in the field 2 years later and something breaks or something has a defect, you can actually go back and see where that happened. But really, you're finding problems and fixing them in the middle of the process before they even happen. Okay, so let's get into some more of the technical details. This machine has actually 3 Z-axes. Now, that's obviously the bed that goes up and down, and then the X and the Y that the nozzles move around on, which are complete IDEX, by the way, so you can do mirror and duplication, multi-material, multi-nozzle, or multiple parts at once. Each nozzle has its own Z-axis, almost 5 centimeters of travel. Now, this comes into play when you're actually printing, but a lot of it's just the pre-calibration. So when you're starting the machine and you're heating it up and you do the leveling and calibration, it's a lot faster. Now, That's actually something to touch on, is the heat up times of this. If you've ever printed in high temp, especially on a large machine, you know it can be turn it on and wait 4 to 6 hours to heat soak the entire machine and all the frame and everything, so that you don't get shifting in between the bed and the heads and get, improper part quality and improper dimensions and things like that. You have to heat up these machines and calibrate them at temperature. And on a lot of the machines, you actually gotta basically open the super hot machine and go in there with a leveling card and different things like that. But on this machine, they've integrated force sensors on each tool head, so you never have to open the machine, and it's giving you extremely accurate calibration results right out the gate. And then for XY alignment, there's a lot of different ways to do that. And a lot of the machines out there, you have to print something and see if the two heads are aligned and then adjust it a little bit, see if they're aligned, and then keep going. That can take an hour, even multiple hours sometimes, especially if you're opening and closing the doors. This machine actually uses a microscope, not just a camera, but a microscope to determine the position of each tool head and nozzle and align them perfectly in a matter of seconds. And it does that all while cleaning and purging that hot end so that you know you're starting fresh and perfect every single time. Now, because while you're printing, it's sensing the force the entire time, this has huge implications for the porosity and overall part quality. So you're getting the data and you know instantly if something is off, if something happens, it'll tell you, and you'll know, okay, this may be an issue with the print process, might be something else, but we can go in there and eliminate that, do what we gotta do so that it goes perfectly. And most of the time, that's gonna be eliminated right out the gate because of all the calibration and sensors, as well as the simulation. If you're interested in a Hylo for your business, reach out today and we will get on a one-on-one consultation to see if it's a good fit for your business. Now, the optical sensors they're using for the alignment actually are up to 2 times more accurate than anything else in the industry. So you know that you're getting perfect alignment between the two heads. So if you're doing multiple materials or support materials, or you're using a big nozzle and a small nozzle, and you need to make sure that that nozzle is perfectly aligned so you're getting dimensionally accurate parts, it's very, very good at doing that. So on that note, let me show you the crazy hot end that they've actually produced. If you look at this thing, it's absolutely like a beast. It looks like a phaser out of Star Trek, honestly. But you'll notice something on here. There's no couplings for water cooling. And everybody asks, oh, when are you gonna put water cooling on the machine? Well, frankly, water cooling isn't always the best option. If you do have to switch tool heads, it's a pain. You got quick couplers, everything else. You spill water everywhere. It's just a mess. What they've actually done is incredibly innovative. And they've basically used CPU cooler technology with these heat pipes here going through the heat sink up here. And that actually is extremely effective at keeping that heat break zone extremely cool. So you get that fast switch between hot and cold, which means you can change materials and you can, stop printing very effectively without all the extra oozing and stuff that we see in a lot of these high performance materials. You also notice down here in the bottom, you've got these cooling jets. These are actually air jets that are shooting out around the entire nozzle. A lot of machines will have a cooling fan on one side of the nozzle, and then that can lead to part imperfections and all sorts of stuff, but this is going 360 degrees, but it's also sending jetted cool air that can be controlled. This is like true high temp part cooling if you need it. And that's where the thermal simulation comes into play, because generally you don't use any cooling on high temp materials, it's just unneeded. With the simulation, we know if you're printing a large part and then it comes into a small area, you're gonna get hot spots, and thermal mass is just gonna hold on to the heat there, and that can actually degrade the part quality, the material properties. It's actually harming the performance of your part. So sometimes you do want cooling, but in traditional methods of slicing, you can't control it by the millimeter of where you know there's gonna be pockets of heat. So this is true high temp part cooling for optimal part strength and quality. We've also got the nozzle itself, which is an M6x1 nozzle, so you can use standard nozzles in here, but it comes standard with a tungsten carbide nozzle, which is extremely abrasion resistant for all your composites like carbon fiber and glass fiber, whatever you're printing that's abrasive. So above the nozzle, you'll notice this entire melt zone, nearly 5 centimeters of melt zone, and it's a coiled heater going around the entire thing. And that actually gives you very, very even heat. So it's not like a heat block where on one side you've got most of the heat and around the other side, it might not quite be there, which is why you really want to pay attention to the engineering of your tool heads and hot ends. But this provides extremely fast heat up and good cool down times. Now here you've also got redundant RTD thermal sensors, PT1000s, and 2 of them. The redundant RTDs ensure that the thermal readings are as accurate as possible. These PT1000s, for engineering grade polymers, you get accuracy down to 1/10 of a degree. So you're extremely precise, and that's massively important to make sure your part quality and your performance is there in the material. If you go too hot, you're gonna degrade it and you're not gonna get the performance. If you go too low, you're not gonna get the layer weld strength and your Z-axis is just gonna snap. So having this integrated and very, very precise temperature is extremely important. If you're interested in a Hylo for your business, reach out visionminer.com/Hylo and we'll get you on a one-on-one presentation. So you have extreme precision while you're extruding the filament over the temperatures, but you also have to think about the material that's not being extruded here in the filament bay. Now, a lot of machines are going to use a filament bay that's heated, but if you're near the coast, or you're pretty much anywhere but Arizona, then you might just be keeping it in hot, wet air. So what they've done here is they've borrowed technology from the injection molding industry with a molecular sieve drying system that is essentially regenerating, lasts up to 2 years. And they focused on maintaining a dew point rating, -25 Celsius dew point, so that you absolutely know that the air inside there is dry. So you bake your filament, you put it in there, and there's no worries. You know it's keeping dry, and you're gonna get good results on your extrusion. And of course, that is sensed and recorded throughout so that you know through your entire printing process it is being monitored. So you're monitoring the tension between the 2 sides, and that helps prevent jams and coiling and all sorts of issues that might arise in other systems we've seen in the past. One of the big things about this is the low maintenance. That molecular sieve drying system, instead of having to throw a new bag of silica or desiccant in there every day, it's going to last 2 years. So that's one big thing. They didn't even have to reinvent the wheel. It's literally technology that's proven and tested for many years in injection molding. And in regard to maintenance, you've also got, standard tungsten carbide nozzles. Those are gonna give you a lifespan longer than almost anything else on the market. And on top of that, the Z-screw in the back, there's one. It's gonna need grease maybe once a year. So what we're seeing from this is some other machines out there on the market with maintenance intervals of days or weeks or months. This expands that by an order of magnitude to where you're doing very little maintenance over a long period of time. And this is extremely important in production environments when you have a fleet of 10 or 20 machines or even more, to keep all the machines consistent. A lot of print farms go through, we've got 100 machines in here and they've got daily or weekly maintenance schedules, and if any of that gets off spec, then you're getting inconsistencies throughout. We've seen entire factories just thrown out because everything was just way too off. All right, so let's take a look inside the actual chamber. Again, you've got that wide format. You've got the 450 in the depth, you've got the 650 millimeters in the width, and 450 tall. Now, this is something that's been trending in the industry because it's actually more useful in general. There's not that many people doing all tall parts, but more of the time we see people doing batch prints of small parts. So you get this entire bed to fill up with your small parts, so you're getting more throughput and more production on a single build. Inside, you've got this beautiful vacuum bed. Now that's important for a few reasons. First off, you can use a variety of different types of build sheets. We've also got build plates like carbon fiber and carbon fiber peak that you can use in here for a rigid surface. Then you've got Garolite, you've got PEI, you've got a slew of different options for your bed material. But furthermore, the vacuum beds are useful because we see these parts and these materials have so much force in the warping that they will literally bend your plates. If you're trying to print on an adhesive sheet, it's gonna peel that adhesive right up. So having a vacuum bed where it's keeping every square inch of the bed sucked down and solid is really important, just for ensuring the bottom part of your part is flat. One nice thing too, because not everybody likes build sheets, some people hate them, AON has always used very thick build sheets. You're not dealing with the thin, flimsy stuff that's just gonna tear when you take your part off, or it's gonna stick on the part. It's just annoying. They use nice, thick sheets and plates to actually have a good surface to print on. Furthermore, these sheets are also reusable, so you're not throwing them out with every print, unlike some other manufacturers that we deal with. Now, if you come inside the chamber and you see up here, we've got this little rectangle thing, and that's actually a drawer that pops out, and that's got the purge bin, the nozzle brushes, and the nozzle microscope for alignment. Now, a cool thing about the purge, there's a lot of machines starting to do purges out there, and as we all know, if those purges pile up too fast, it can ruin your production, it can ruin your print, it can jam, and then you gotta fix it and then keep your print going or even restart it. Their purges are so small and the bin is so large that you can go months of printing without even having to empty it. Once again, that's lengthened maintenance intervals. Very good for production. If you're interested in a Hylo for your business, reach out today and we will get on a one-on-one consultation to see if it's a good fit for your business. Now, you'll also notice these seals, which go around the entirety of the build plate. And of course, the bellows up top, which means when you're starting a print and the bed is up there, that's your entire thermal area, compared to some other machines where you have to heat up the entire machine. And not only that, you have to wait for the entire machine's structure to heat soak. AON has integrated an athermal structural loop, meaning that all the hot components are separated from the cool components and the structure and everything else. So they heat up the correct components, the rest of the components are cold, and you don't have to worry about heat soaking your machine for 4 to 6 hours before starting a print. You can start printing engineering materials in as little as 15 minutes. The materials like PEEK heating up in around 45 minutes to less than an hour. So instead of coming in the night before, turning on your machine on a Sunday night and letting it heat up overnight so you can start your print in the morning, you just come in like a normal person, turn on the machine, wait 15 minutes, and start your print. Huge game changer for High-Temp. That heat up time also applies to material changeover. If you're printing ABS parts, then you need to switch production over to PEEK. Not only is the hot end a single bolt in less than a minute to change out, but you're not sitting there for 6 hours waiting for the machine to heat up at the end of the day to start your print. You're gonna start in less than an hour. So that's a very, very big deal. And one more thing about the chamber. The way they've designed the hot air blowers to keep the whole chamber consistent. I mean, on some machines we'll see blade fans where it's blowing air across the whole bed, so it's technically hotter on one side than the other. Some machines use infrared, other machines have different blower systems. What they've done in AON is they've used 2 extremely powerful blowers, and you'll see up there on the back left and the front right, this creates a consistent vortex inside the chamber, which is super important for consistency across the bed of part. If you're doing it where it's blowing across the bed, then the parts over here are gonna have slightly different properties from the ones on the other side. But the way they designed it here means that the entire chamber is gonna have much, much more consistent thermals, which means your part quality and your part consistency is gonna be above and beyond anything else on the market today. Now, on top of that, they haven't just made it for printing materials. This is really an experimental machine. It allows you to do experiments because they've got these super powerful blowers. Sometimes you need that. There's a lot of different applications that haven't even been tested, haven't even been tried by anyone in history yet, that are gonna be enabled on this machine to figure out new processes and new ways of doing things. And frankly, just with the baseline system of Basis and the machine, their software with the hardware, we're already reaching capabilities that we've literally never been able to see before. There's parts, thicknesses, geometries that simply could not be done are being done on this machine in extremely high performance plastics, as well as all the lower commodity grade plastics. All right, so with all this talk on software and hardware, you might be wondering, well, does this thing even run G-code? Like, can I trace that back? Can I get quality control on that? And the answer is absolutely yes. This machine actually runs standard G-code. Unlike other machines where it's like you don't even know what's going on behind the scenes, you can use different slicers with this that then integrate into the thermal simulations, Basis, the different testing methodologies and whatnot. And on top of that, if you need to air gap it, maybe you're a defense contractor or something like that, and you can't have this thing connected to the internet or Wi-Fi or anything like that, it runs flawlessly. From the ground up, it was built with our DoD in mind. One of the nice things about AON is that they really started on a foundation of material science. So when you're using the machine and going through your parts, not only do you get the support from us at Vision Minor, but you get a dedicated engineer and the team over at AON. So if you don't know what material to use, or you're figuring out the best way to design for additive for your parts or how to scale production the most effective way. You have multiple teams to help you out and keep you producing parts and making money, saving time with your 3D printers and your production. If you want to know more, obviously go to visionminer.com/AON3D. Give us a call, shoot us an email. We're here to help. You can leave a comment down below with what your thoughts are. Where do you think this is going to take the additive industry? All these sensors, all these AI and machine learning. What do you think? Let me know in the comments down below. We love hearing from you guys, hearing about your projects. Thanks so much for watching. Positive rest of your day. I'll see you in the next video.